Hello and welcome back. We have our third presentation. It's going to be a two-parter. Mark Wallace is going to talk a little bit more about the concepts of SemOps and its involvement of continuous deployment of ontologies. And Katriana is going to be talking a little bit more about how to apply that architecture from a practical perspective. So take it away, Mr. Mark Wallace.
Hey everybody, this is Mark Wallace with Semantic Arts, and we're going to get into the semantic operations or the SemOps session. So I hope you're enjoying the conference so far, and let's get started. Okay. Again, I'm Mark Wallace, and this session is DevOps for Semantic Systems. And what we're going to do is I'm going to give kind of an overview of things, and then my partner in crime, Kari, is going to get into some real-world examples, a case study. So, quick little bit about me. I'm an ontologist and software architect developer. I have decades of experience designing and building data-centric systems. We didn't call them that back then, but I always seem to find myself working in the data world. I've been involved in the semantic web side of things since 2004, and in addition to being an ontologist, I've built some very large semantic systems up in the billions of triples, even back as early as, say, 2013. Been an invited speaker at Semantic Web since 2009, and currently working for 4 different clients, manufacturing, financial, doing ontology and knowledge graph work. So my LinkedIn information is there. So that's me. So what are we going to talk about? We're going to define what is SemOps. That's going to be my job, hopefully first 20 minutes or so. And then we're going to move on to kind of a real world example of SemOps with what Katarina has done with the Zalando knowledge graph. So that's the plan. So let's get started. The first thing I want to do is kind of talk about what is DevOps, not exactly SemOps. SemOps is a term that we've kind of coined at Semantic Arts to talk about what would DevOps mean for semantic systems. So I want to ground people into what is DevOps. So DevOps is a set of practices that combine software development and IT operations. And the goal is to shorten the systems development lifecycle and provide continuous delivery with high software quality. So that's the Wikipedia definition. The definition from the Software Engineering Institute is about the same. A set of practices intended to reduce the time between committing a change to a system and that change being placed into normal production while ensuring high quality. So as you can see, really the goal in both cases is how do we shorten this time to get new things into production, but make sure the quality is high. And so the key elements of a DevOps methodology are the following. So first off, there's source control of your software versions, right? You need to make sure you're not just running with something that one of your developers created on their machine, but you know exactly what software version you're on and it's under control. Then there's the automated build and regression test of software versions. So not counting on some human in the loop to sit there and kind of do it on the computer and you hope they did it, but how do we automate that so that when the software changes, we can automatically build it faster and more consistently, that we know every time we make a change, we have a new build version that's ready to go. We also want regression tests of that software. So someone checks in a new version, we want the system to kind of automatically go into a test suite that verifies we didn't break anything. Software still acts as expected. Another key element of DevOps then is automated deployment of the new software version. So assuming it's been able to be built and it's packaged up and compiled if it's that kind of a language, and then it's tested and it's passed all that, why wait? Let's now be able to deploy that automatically and get that software, that change or those changes, into production as quick as possible. So again, you want to automate that. You don't want to be relying on people on their computers clicking and pointing and dragging and stuff to get that deployment out there. They may make mistakes. You'd like to automate it and have it be kind of surefire and fast when it happens. And then lastly, once you've got the software deployed, you want to do some continuous monitoring, because let's face it, it's always possible that the change broke something or created a performance issue or something like that. So you want to sit there and watch it and have automated tools that continuously monitor and look for problems, errors, or slowdowns, or things like that. So the DevOps world has these things called tool chains, right? And it's a set of tools that kind of work with each other and maybe chain together from the, the build, the check-in of the code, to the build, to the test, to the deployment. So I want to talk a little bit about this idea of tool chains and talk about what they are in the DevOps world quickly, so we can maybe think about them, what they might be in the SemOps world. So going back, for the source control of software versions, the tool chains include things like Git and GitHub. If you've maybe some of you have heard of those things, places where you can check in new versions of software, create new branches of software, merge them back into the main line once they've been reviewed. These have online code review capabilities usually, so you can have peer review by other developers, and they can make comments and kick it back for more changes. So that's the sort of thing that GitHub, and there's similar other environments as well. GitLab is one I can think of. So that's your source control of software versions. There's also tools for the automated build and regression test of software versions. This means it'll automatically build build and test the software, running predefined regression tests right when you check it in. So you don't have to consciously remember to make that step or waste time trying to come up with that. It's just every developer, when they check it in, you can set it up to where it's going to do that test. There are things called unit test frameworks, which do this regression testing. JUnit is one for Java. There's PyTest for Python. Most modern languages have unit test frameworks. And then there's also packaging. So you test the units, but then you want to package them up into the complete application. There's automated packaging tools, Maven or MVN, RPM, NPM. There's GitLab, is another thing that's kind of like GitHub, and GitLab CI is continuous integration. So you can write scripts that say, here's all the things that you should do to package things up once the software cleanly passes the build and the test. And there are tools for the automated deployment of the new software versions. So you've tested them out. Now you want to do what they call continuous integration. Some people call that CI. So that's where you want an automated workflow, or possibly sometimes they have a human in the loop for certain cases, meaning a human will see that it worked and they're going to wait on the human to push the button to move things, usually through a series of production, or a series of environments that are working their way toward the production environment. So for example, you may automatically deploy to the dev or the development environment, execution environment as soon as it gets built. And maybe you'll auto deploy to the test environment as well, but you may not auto deploy to staging. There might be human in the loop, there might not. These tools allow you to do those kind of things. Jenkins is a tool like that. GitLab is a tool like that. So, and lastly, continuous monitoring. As we mentioned, there's tools that will monitor infrastructure, that monitor particular application performance and errors, or monitor the network. Sentry, App Dynamics, Dynatrace. There's a whole series of tools that do this kind of continuous monitoring. So with that, let's move on to SemOps then. So what is SemOps? Our very own Dave McComb had this to say when we kind of first started thinking about this topic. SemOps is both a methodology and tools that will allow an ontologist to push a change into production in the least amount of time with little risk. It will involve detecting which changes are likely to have adverse impacts and testing. So that's what Dave had to say. And then I think if you look back at the Software Engineering Institute's quote, it still stands, right? It's a set of practices intended to reduce the time between committing a change to a system and that change being placed into normal production while ensuring high quality. Okay, so, for ontologies and semantic web, as opposed to kind of the generic software world, what's this going to mean? Well, the idea of source control applies to ontologies as well, right? We need the source control ontology versions. We can use the same tools. In fact, we at Semantic Arts do use Git and GitHub to control gist, and many of our clients have their own internal Git-related hubs, maybe Stash or Bitbucket or things like that. But the point is, let's don't just have it on someone's desk where some guy messes with the ontology. Let's have it in a source control system. We can do online review of changes as different ontologists were trying to make change to the ontology. Let's use precise versioning. So let's start associating 3-digit version numbers with the ontology. And if you go out and look at semver.org, it sounds semantic, but it's actually, they just mean it in terms of there's meaning to each position in a 3-position version number. It's not for semantic systems, it's for any system. But apply that precise versioning, because then each of those positions can tell you something. Usually the smallest position just means there was a bug fix. The middle position means there was kind of a feature change. And the highest position, like a 2.0.0, means that essentially you have a kind of a breaking change or a non-backward compatible change. So, we should get in the practice of versioning our ontologies in such a way so people would know, oh, if I have just 9.5.0 and then I change it to just 9.5.1, that's a 3rd position change. It's probably just a bug fix. It's probably not going to change. It's not going to change any concepts I use, etc. It's probably a low risk change, as Dave mentioned in his definition, identifying what kind of is likely to break and what's not. So let's become rigorous about controlling our ontologies, as well as versioning them in a semantically meaningful way so that we know the impacts. This is, we may also move. I know we at the Semantic Arts have been talking about the data-centric architecture, and our goal is to have even the ontology changes happen within the triple store. Since you can store ontologies as triples, it may get to the no files state. But the whole point is it's still very controlled, right? You know exactly what changed version to version. You could get back to an old version, et cetera, et cetera. So that's source control. What about automated build and regression test, for ontologies? What does that mean? And so, well, first off, ontologies have this notion of logical consistency. So you want it to automatically, when someone wants to check in a change, do some logical consistency tests. Did I make the ontology, logically inconsistent or not? That's a basic one. You certainly want to know if you messed that up. You would also do inference tests, right? Am I getting the same inferences I expected before? You want to do query tests. All of this can be done, I think, and I've done some examples at Semantic Arts, very similar to the way existing regression tests work. You have a small amount of data, you pair it with the ontology, you run the reasoner, and you verify that you get the answers you expect. And that's the way most regression tests work in regular software. If you don't get the same as the expected result, you throw an error, and essentially you kind of say this version is not ready for prime time. It doesn't reason properly. It's not logically consistent. Another thing that harkens back almost to our C programmers and stuff, but this idea of lint checking. So lint in a piece of software, it's just kind of stuff. It's not officially an error. It's just kind of messy, or it's dirty, or you left stuff hanging around that you really shouldn't have in there anymore. The idea of a lint checker in the semantic world on an ontology might mean you have missing annotations, right? You've declared a class but not given it a label, or not given it a textual definition, maybe. Maybe you have a standard that says all of your concepts need some sort of shackle conformance check. Shackle is a shapes constraint language that you may have heard of already. So the shackle shapes would say, here's the way the graph should be shaped. If you've got concepts that don't have anything constraining how they're shaped, you may decide as an organization you would like to check and make sure you have shackle for all of your classes, for example. A lint checker might also be able to check for affected sparkle. It might look and say, okay, given the new ontology, you have some sparkle queries in your query catalog that don't use the same, they use a property that's not in the ontology anymore, or something like that. So how would you identify that you have some of your queries are not using the same concepts as your new ontology version. Examples of a lint checker approach that would be helpful as we productionize ontologies. And also automated packaging. In ontologies, this might refer to serialization, right? I can define an ontology, but maybe someone wants it in JSON LD, someone else wants it in a trig format, things like that. So you shouldn't have to have some ontologist sitting there in Protege, pointing and clicking and doing exports to different formats. That should be something that can be very automated and done by the machines to create the right serializations that you think you need. Possibly injecting the versioning. Maybe you have versioning in your source control system and you want to put those into a version IRI in your ontology. Maybe we can automate that, not make that something that you hope a human gets right. You could automate annotations. Possibly you have an ontology that you've annotated by your own standards in SCOS, but you have a client that wants to receive them with, say, RDFS label instead of SCOS labels and things. Again, instead of having some ontologists go and do that by hand, why not automate that as part of the packaging and have an option to add RDFS type labels or SCOS type labels or something else? And certainly release note automation that would show what changes went into this ontology would be a great idea. Let's move on to deployment. What does it mean in terms of deployment? Well, first off, just deploying the new ontology itself into the different environments. Again, these environments in a data-centric semantic knowledge graph, the ontology lives there in the store with everything else. So you'd want to be able to automate that and move it through the different stages of from development to production. You'd want to be able to check that the knowledge graph still conforms to the new ontology. What if you changed a concept, you renamed a class, or you added a new class, or you changed a property name, and the knowledge graph, you don't want the knowledge graph using constructs that aren't in the ontology anymore. So you'd want to automate as part of deployment, making sure the knowledge graph is still conformant, and that could have a few aspects, right? It could be that you want to change the data in place in the knowledge graph, which means you need to do a data transformation. As the new ontology is coming in, we got to make sure the knowledge graph follows that new ontology schema, and that might mean changing data in place to conform to the new ontology. Or you may be building your knowledge graph through some data generation pipeline, kind of an ETL approach. So you'd want something to automatically update the data generation based on the new concepts, or at least check it. But you'd like to auto deploy that. So your data generation pipelines will now be conformant to your new ontology, and you want to synchronize that. So when the new ontology goes out, the next data generation ETL happens, they match each other. Furthermore, maybe it's a third thing. Maybe you're doing data virtualization. So you're not, it's not so much you're doing an ETL, but you have RML or R2RML or maybe a proprietary language that is taking some data store and virtualizing it into a knowledge graph. And if you're doing that, you would, again, if you're changing the schema, which is the ontology, you're going to want the virtualization mappings to change as well. When you read from this table, make it this class. If the class name changes, you better make sure your data virtualization changes in synchrony. Similar with Shackle. We mentioned Shackle is a constraint language to make sure the graph is the right shape. So you'd want to make sure that the new Shackle that matches the changed schema gets synchronously deployed at the same time as the knowledge graph is, has been reconformed to the new ontology. The new ontology is in there. You want to make sure the Shackle is also paired up, right? Because if any of those things are out of sync, you're going to get errors. And that same thing would hold true for Sparkle, right? You would want to make sure your Sparkle query, if you have, say, a query catalog that's conforming to the ontology, you want all that to sync up at the same time, so you're not using queries based on the older way, the old schema or the previous version of the ontology, trying to query data that's in the new version of the ontology. And lastly, getting to continuous monitoring. So, here again, once we deploy a new ontology, change the knowledge graph, deploy the Shackle, deploy the Sparkle queries, we want to monitor what's going on. Is the application that's using this knowledge graph still working well? Is the infrastructure still running well? Are we getting shackle conformance errors? You know, that would be a telltale thing that either we didn't update the shackle right, or you know, something's gone wrong. We didn't update the knowledge graph right. If we're starting to see a lot of errors in the knowledge graph conformance to the way the schema is supposed to be, you know, we want to be told that. We don't just want to hear about it on the street. You know, we want to make sure that our tools are looking for shackle errors and telling us there's a problem. Similarly, query performance, right? We'd want to know that that our queries are slow. Some of them or some of them are getting errors when they run, or they're maybe returning 0 results when they didn't used to. So we'd want some continuous monitoring to make sure these things are in place. And lastly, you know, the idea of automated rollback, which most DevOps type, you know, structures have, right? When you want the ability to put a new change into production and have it work. But if, you know, if that doesn't work, you want to be able to get back to the previous version that did work. You want then, and you want some automated way to do that. So again, you don't have people scrambling around trying to do it, but you know, the system could look for a certain number of errors and just say, if I get to this threshold, we're gonna roll things back. So that is it. What I want to go to next is Katarina. So let me stop sharing my screen and see where we're at here. I wanted to hand things over to Katarina, and so hopefully what she can do then is take us through an example of some, you know, DevOps or SemOps, really, some semantic automation and putting a real knowledge graph into progress, or on a big knowledge graph. So Katarina, I'll turn it over to you.
Well, thank you, Mark, so much for what you were presenting, because I mean, yes, we have applied some of the things you mentioned, but we're looking at your presentation. I'm like, okay, we need to do that next, and I think we need to pay attention more to this, and that's certainly something we could be automating. So it's a bit of a continuous, not only continuous development, but a bit of a continuous process of getting the team there, right?
Nice.
Anyway, so briefly introducing myself, you can see on my slides, there's just a bit of information of me. So on the next slide, you can see I'm employed by Zalando, and there I'm calling myself a knowledge engineer. I guess my title still formally is software engineer or data engineer. But I'm also an ontologist, and I have been defining ontology since 2008, partly in research, but now also in the industry in Zalando. I'm a co-contributor to Zalando's fashion knowledge graph. I mean, I've been talking about that project. I've been writing about it and then talking about it since 2017. And it seems to be very interesting to a lot of people that a company like Zalando, which I'll be telling you soon what Zalando is, because not everyone might know this, but it's certainly not one of the big ones. So previously it was like, oh, Google has a knowledge graph, or this big company is using a knowledge graph. But the fact that an e-commerce platform like Zalando is using a knowledge graph seems to be still news to a lot of people. And I guess that's why I'm also talking here about the subject. Maybe as like a fun fact to know about me, I also happen to be, as a side job or as a side interest and hobby, I'm also an entrepreneur, talking to classical music organizations on how they could use digital means to grow their audiences and connect with the new generation of people. So that has nothing to do with today's presentation, but it might be fun to know that I'm not all about knowledge graphs and ontologies. So on the next slide, you can see that the things that I want to talk about. So I just want to give you some information of what Zalando is and open that up a bit. And then I want to define the way in which knowledge graphs are understood at Zalando. So the way we've defined a knowledge graph. Then I want to show you what we're actually using this fashion knowledge graph for at Zalando, and then talk about the continuous development of the knowledge graph. So on my next slide, you can see a few figures of Zalando. And Zalando is not really something you might know in the US, because it's completely based in Europe only, but it happens to be Europe's biggest e-commerce site for fashion. And eventually our vision is to become the #1 destiny for fashion and the starting point of fashion, so to say. What you need to know, I mean, Zalando has its headquarters in Berlin. It's a German company, but it operates in 17 European countries, which means 12 different languages. So that's already kind of good to know, and that will play a role later in the knowledge graph. What's also really interesting about this number is we have over 35 million active customers currently. That's a lot of data, especially about how the customers are interacting with Zalando. And this means that we can actually comfortably do A/B testing. If we want to roll out something, a new feature, or maybe even create new experiences with the knowledge graph, we can do that. We can show it to a fraction of our customers and already start measuring the impact. And that's really valuable, and we'll get to that later during this presentation. So going forward to the next part of this is how do we define the knowledge graph? So you can see on the next on this image, done like this exact image with the shoe in the middle. It's kind of my picture I like to draw for you about the knowledge graph. So what we have here are nodes that are fashion concepts. We call them, for search of a better word, fashion tags. And fashion concepts can be things like a high-heeled shoe, or a dress, another shoe, jewelry, beauty products, handbag. But it can also be other concepts, such as the beach. So the context of where clothes are worn, not only the clothes themselves. Or something like a style, so business style or formal style, sporty style, street style. It's really a variety of very different kind of concepts. And the way we structured our knowledge graph is using structural or associative relationships. Structural relationships are things that, if you're familiar with ontologies, you would know them. It's subclass of, RDF is subclass of, or RDF type. It can be any kind of part-whole relationship you might be using or define, depending on your vocabulary. And those are the ways to kind of say that, well, there's a shoe, but the finer definition of a shoe can be like something like a sneaker or a high heel shoe. And then you have something like a kitten heel shoe. So you might be like distinguishing between heeled shoes and non-heeled shoes or soft shoes or whatever. So the distinctions can be very different. And we have a lot of discussions with our domain experts on this subject. But then for like the associative relationships, they are different. Like they kind of, if the structural ones are defining top to bottom, top being very general, bottom being very specific, fashion concepts, and on each level you have different kinds of fashion concepts, then the associative ones go in lateral directions. So you can have a connection from beach to bikini. We're associating the beach with bikinis and vice versa. Usually the associative relationships are also symmetric relationships. And this helps us to kind of do other things. And then we also have, I mean, we're doing a bit of OWL, same as relationships to other vocabularies out there, but not much of that. That's really the basics of the ontology and how it's structured. The identifiers we're using the IRI standard. So if we just go to the previous slide still, so the identifiers we're using is the IRI standard, which internally also work as web pages. So they've been created as URLs. And as you can see, all of this is defined using RDF. And so now we can move to the next slide. And here you can see where we're actually using the fashion knowledge graph. The fashion knowledge graph creates for us a semantic layer to understand and speak our customers' language. So, I mean, we can have product data, like data that describes the products themselves that are sold. We can have very specialized wordings, very standardized because of various reasons. But our customers might not use that exact language that's being written onto products. So our customers come to a website and they interact with the search bar, and they might be typing things like appropriate for the beach, or light colored cardigan, or colorful cardigan, or winter, like winter shoes. And the thing is, winter is actually, like winter was one of the cases we solved for a lot of customers, but winter is a concept that is not written onto products directly, because products are more like down jacket or woolly cardigan, or this kind of coat that uses this kind of heat technology or whatever. So what the product data is explicitly saying is something that implies that it's good for winter. And this like implying that something is winter, that's what you really need a semantic layer. So what we've done is we defined concepts that our customers are looking for, like winter or light colors, or something like tough jacket, like what does tough mean in context of fashion? And then we create this kind of either rules or machine learned connections to what products those actually are. So that when a customer goes into search and type winter, they will get see actually products that are suitable for winter. And then we can also give the best possible view in browsing. So if our customers are kind of browsing the shop, we can give them context to why they're seeing certain things. On our next slide, what you can see is the value proposition of the knowledge graph. So this is what we're promising the business. This is how we're telling the business, it makes so much sense to keep on investing into the knowledge graph. What we have shown is we have low performing or no hit searches. And because we have those millions of customers, we can really well see which search is really not performing well. There's a concept such as winter skirt, and this is very specific to Italy. It just seems that, and we still have enough of Italian customers to see that we need to make sure that we are catering to the search of something as specific as winter skirt. So, and we have shown that with just a handful of really well-defined fashion concepts, we can definitely improve a lot of search results for a lot of customers. And then all of this is translated to 12 languages. So we're also monitoring constantly our customers throughout different language domains and catering to those specifically. And what we've done is we've created a dashboard where we're all the time monitoring if when we're introducing a new fashion concept, if then the results, like if customers are actually interacting better with the search results. And we've proven that we have significant monetary improvement, like customers actually end up buying things more when we've defined the fashion concepts better. And the other thing which seems to be very valuable is when we're doing recommendations on Zalando's website. So a customer is browsing through certain clothes, and we're giving them recommendations. You might like these clothes as well, or these other products. And we are providing them context. The fashion knowledge graph actually drives them to tell them why they're being recommended these things. And that seems to improve customer happiness as well. Like, at least they seem to be clicking more and interacting more with those recommendations. An example of this recommendation can be something like, oh, you're looking at a blazer currently. Well, why wouldn't you like to, or would you like to see more of these products that are also from of the style business? I'm wording it in a very clumsy way, but basically I think my colleagues created this really nice title, which is like other business products that you might like, something like that. And so this way the customer is like, oh, Zalando understands that I'm looking for clothes for business. And all of that is driven by the fashion knowledge graph under the hood. And how it is done is the blazer has this connection to the fashion concept business. So that's been connected because we've defined how it connects to it. And then the recommendation engine takes that information in, is saying, okay, from other products I would recommend to this customer based on their personalized, like there's a whole personal profile and those kind of things. So from that pool of products, I'm just going to recommend the ones that also have the fashion concept business. And then I'm also putting this business text, the label, in whatever language we're talking to the customer. I'm putting it into the title so they get a feeling that we're actually providing them context. So that's really how we do things at Zalando, what we use in fashion knowledge graph for. And next, I will go into more of the technical things of continuous development. So what you need to know about the continuous development of the fashion knowledge graph at Zalando is that the technology we are using is GitHub, Docker, and Kubernetes. We have our own version of Kubernetes. I think we call it something like Zcube or something clumsy like that. It's fun. It's just a kind of few things we've added. We're using something very similar like Jenkins, but also our own internally developed thing. And all of that we call the continuous development platform at Zalando. Go to the next slide of continuous development of the knowledge graph. I've drawn an architectural, so the next slide after this one. I've drawn an architectural image where you can see the whole process. And I mean, I'm looking at this, I'm a hope that with my explanation, you'll be able to understand a little bit better how we're doing things. It's very much along the lines what Mark was telling about like how you can manage different stages of your deployment. But basically, the whole thing starts with kind of we're actually like we are managing the core of our like the fashion concepts themselves, which we call the core of the fashion knowledge graph, because the fashion knowledge graph has a few other things there as well. But the core is made out of these fashion concepts I was talking about. They are actually maintained as files, as TTL files in GitHub. And so if we want to change or if we want to introduce a new fashion concept, that will be done via a pull request to that GitHub repository where they live or where that file is. And once the pull request has been created, it immediately creates a new version in staging. Actually, it's actually our test branch, so not like the test branch, and then that already like that already goes into, like, if we have applications in staging, we'll be able to see the new version of the knowledge graph immediately, but it's still not exposed to our customers. So we have a safe environment where we can test these things out. We can see how well the fashion concepts work, and if it all like looks good in our applications. If everything is all right, it will be reviewed anyway by other people. So we're implying something called the 4I principle. That means 2 people have to actually review the pull request and review the changes. And if everything is okay, or maybe some changes are done, and in the end everything is okay, then that pull request is merged into the master branch. And when that happens, then that's when this change will go to production and will actually be exposed to our customers. All of that, how it is exposed, is driven by Kubernetes. So like in Kubernetes, we then have a script. It's all orchestrated that pushes the changes into an S3 bucket on AWS. And then we have another script that then updates our triple store that's in our graph database, AWS Neptune. It updates that through that S3 bucket. Once the changes are in AWS Neptune, we can already see a few of our applications having the newest fashion concepts. So one application is where we manage all the different language versions of the labels. So what we do is we define the labels in the GitHub repository, I think only in English. At some point we were managing also in German. I think that has changed a bit, that we're only managing them in English only. But sometimes it can be like English and German. It's just because German is so prominent in Zalando. And then that means for the rest of the 10 languages, we still need translations for all the new fashion concepts that have been done. And that is actually done via this tool that you can see where is kind of used by an actual domain expert and language expert. Then the other application is the actual website. So remember when I said that each fashion concept has identifier in the RI form? It also and also web pages created out of that, where internally we can browse to, and that is an application that is directly talking to AWS Neptune. Also, we on that website we also have a visualization of the whole fashion knowledge graph. Which you can see here on the right. That is something that can be zoomed in and clicked on and interacted with. So all of that is driven from this live Neptune instance. What's also happening is each fashion concept is published in a message broker. We're using Kafka, and we have like our own open source development called Kari, which is based on Kafka. And so we have this message queue where all the fashion concepts are published from. And then, I mean, at Zalando, all our applications are basically connected via these message brokers. So then if we really want to, so if we've published a new fashion concept, it will be published in this message broker once it goes to production. And then Zalando Search, which is its own monster, its own like whole team or teams doing it, they are consuming our Nakati stream for fashion concepts, and 25 hours later from going to production with the new fashion concept, and 25 hours later, it is live on Zalando Search. So we always have a bit of a delay, and that's just because of indexing, because we have so many products, over 500,000 products, that it just takes time to re-index everything, and it's done every morning. And then we have also other internal apps that might be wanting to consume the fashion concepts and use it for their own ways, and they are also not getting their information from the triple store directly, but actually just consuming the message queue, which we call Nakati at Zalando. And so next, I would like to just show you how we can do an A/B testing. So that's my second architectural diagram, and I hope you can understand the picture. So if we go to this, next slide is, yes, a pull request again of like, if we start on the bottom left, a new change comes in, maybe like we're introducing just one new fashion concept. And we want to see how well customers are actually interacting with it, if this fashion concept is solving a customer problem we've identified. And so again, a pull request is submitted to GitHub or to our repository in GitHub. And that pull request branch is then picked up by another team different to us, which is only responsible for all the A/B testing that's happening in Zalando. So we are like not the only team that is wanting to do A/B testing. So they have like a careful schedule of when what is A/B tested. We need to get our time slot there and define what's being tested and how long the testing should go for, and what percentage of the traffic should be given for the test branch. And so we notify them that this branch, this pull request branch, you can find it here, like we're given the identifier for it. And it will be like they're picking it up from Kubernetes again. And then according to their schedule and their timeline, they're conveying the traffic. If we said, okay, 50% of our customers should see like the regular current status of fashion concepts, and 50% also get this new fashion concept or can interact with that new fashion concept, then they will give a 50-50 split for the traffic. But this could be like anything. This can also be 90% and 10%. We're really lucky that even 10% does matter. And this was really how we also measure that we are actually improving customers' experience, and we're improving the way in which customers are interacting with search. So when we started this whole project, what did we do? We just defined a handful of concepts which we think would have improved search. And we tested everything just in the German market with, I think, 10% of the German traffic. And we could already, like in just 2 weeks of testing this out and being live to 10% of the customers in Germany, we could see, okay, those 10% are much more happy about certain search results and kind of clicking and end up buying things or end up putting them on the wish list much more than the 90% who are not getting the benefit of the fashion concept. And this was like really useful. So that's the story. That's the continuous development of knowledge graphs at Zalando. And I just have I'm really happy to now take questions. Also, if you have any questions to Mark.
I had a question. I was glad you talked about the A/B testing, and I was curious, like, so do you have like 2 different graphs then, or multiple graphs, and you've actually got a different graph that the search is working its way through for the German 10% versus the other? Are you deploying multiple graphs, or are you handling that some other way?
Yeah, so the way we have is we just have an amendment to the knowledge graph. We have like defined 2 more fashion concepts. And that is like a new branch on GitHub in our repository. And then that branch is being used by the team. So it's kind of just using the newest staging version of the knowledge graph instead of the productive version. Cool.
And I guess I'll be looking in the event buzz to see where different questions may come up. So if anyone has questions, throw them down in there.
Yeah, and I understood that we should like move to session room 1 next to get all the questions. So Sorry, I mean, this digital conference is a bit of a new thing, but I guess what we want to do now is if anyone has any questions for Mark or me, please navigate to session room 1 and we'll take all your questions there, and it'll be a bit of a more interactive thing. It's like us coming down from here, the stage, and then meeting you in session room 1.